So if you go to the course website, you will see that under lecture notes, so that's the tutorial today. So we got a PDF there and also code example. So that's the complete code example you can import to your Eclipse. Download that, import the archive as usual. Okay, and also I include basically almost all the code in the slide, so you can also have a look side by side. Okay, let's start with this example here. Remember back in the lecture on generics, we talked about the book example. So let's build on that, okay, to see what we can do. Okay, so now let's say we want to implement an ADT. Who remembers what ADT stands for? Very good. Okay, good. Abstract data type. So whenever we talk about an abstract data type, let's say in this case we want to implement a book. In that case, let's say we want to support 3 operations only 3 easy ones. So let's say we have an interface called book. It's generic. And then we want to support 3 methods. We have to support size. You should be very familiar about what should return. And also we have a method called add. We want to add a new name and record pair into the book. And also we want to get, given a name, we want to return the associated record. There's something to note here. When you were doing assignment 1, if you want to add an entry into the dictionary, if the word already exists, you will actually throw an exception. That's what we did in assignment 1. For this particular tutorial, we're going to do it slightly differently. Let's say this. Let's say I want to have a phone book like this. Let's say I'm going to use 2 arrays. Let's say somehow Jim over here, 2 arrays. So one for the names, the other one for the record. Let's say I already have 1, 2, 3 for Jim. Now, if I want to add, and then Jim, let's say another number, 4, 5, 6. According to what you have to follow for assignment 1, this will throw an item exceeding dictionary exception. But in this case, we're going to do something different. Okay? We don't want to throw any exception. In this case, if you find that the name record pair you want to insert, the name already exists, you will simply just overwrite this value here by whatever the new value is. Okay, that's a new behavior you want to implement. Okay, that's one thing. And also for the get method, in assignment 1, if the name does not exist in the dictionary, you will throw just another exception to say the word does not exist, word not found, or something like that. But in this case, if the name does not exist, you simply just return null. Okay, no exception, which is want to make it simple. Okay. Okay, so that's the interface. Let's go on. So we actually have, there are 2 ways to implement this. So you can either use 2 arrays, like what I draw on the board, or there's also something for you to do as a case study. I also supply the code to you. You can also use the link list library class, which we briefly showed last presentation, right, in the last Friday. So you can also use 2 linked lists from Java library classes. Okay, so either one. So now in both cases, we're going to use one container to store the names, and the other one to store the records. Okay, basically the same strategy, just using different data structure. Any questions so far? Follow? Okay, that's a simple problem we're going to deal with. So I'm going to just walk through the implementation code with you very quickly to get an idea. And then the most important thing is how do we test these 2 implementations. Okay? So now this is the architecture we're going to have. We're going to have 2 classes. One is called array book. The other one is called linked book. So this class here is going to use 2 arrays to increment the book interface. And this class here is going to use 2 linked lists to increment the book interface. Okay, both of them are going to increment the interface. And when you try to use the book, you can simply declare, let's say you want to use it, you can say book, let's say I'm going to store as a phone number as string. If I simply declare this, because polymorphism, I can switch between dynamic types, right, between the shapes. In this case, how many possible shapes do I have for the book? How many? According to the hierarchy there. Agent, how many? So what can be the dynamic type for books? 2, right? So either array book or linked book. Yeah, very easy. That's polymorphism. Yeah. So 2 possibilities. Okay, let's see this. Let's talk about the first implementations, the very first one. The first one, we're going to have a class called ArrayBook. And it is going to increment the book interface. You can see it in your handouts. So we got the handouts. So now we declare two attributes. Both of them are private. They should do the same for assignment 4. Okay, all the attributes should be private for encapsulation. So now we have an array of string conames, an array of E. So E corresponds to this E over here. Okay, if you instantiate E over here as string, like what I put on the board, every occurrence of E will be replaced by string. Okay, as we learned from the generics lecture. Okay, we also have some counter here to keep track of how many entries we have in the book. Okay, that's basically what we learned from the review lecture. Let's say the maximum entry is just 100. Okay, just for now. Okay, so that's a constructor. We simply initialize an array of certain size corresponding to the maximum capacity, and also we create a new records array, names array, and also initialize the counter to 0. Okay, standard job that we do. And then the size trivial. You just return the value of the counter. Right? That's why it's easy. So far so good. Let's see how we can implement the put and get methods. Okay, how can we put a pair into the array? How can we get the record from the book? So we define an auxiliary method. It's a helper method we can use. So this method here is easy. We simply say, given the name, we want to figure out where exactly the name is. For example, let's say if you say index of Jin, it is going to give you 0, right? It tells you it is in 0 position. If I give some non-existing name, you just return -1. Okay. So now, how do we write it? Okay, the loop is here, so you just initialize counter to be -1, use some Boolean variable here, and then just write a for loop. As soon as you find out the item is there, just return the index. Okay, that's a very standard loop that we did in the Java review lecture 114. Okay, and then eventually just return the index. Okay. So now, after we have defined this auxiliary method here, we can define put and get rather easily. So now, let's say, how do we increment add? First of all, we want to figure out if the name here exists already in the book. If it does, we have to override the associated record. First of all, we just call the auxiliary method we just defined in the previous slides to see where name is. If it happens to be -1, that means the name does not exist yet. Otherwise, it is already there. So now, if the index is less than 0, that means it's not there. So it's a brand new pair to be inserted. So we simply put that into the end using a counter value. Okay? And then, otherwise, the name is already there. So we simply just use the index to go to the corresponding position in the records array and override it. Okay. And for the get, that one is also easy. We can, again, we figure out where the name is. If the name does not exist, which means the index is negative, we just return null. Otherwise, just return the record at the corresponding position. And that's the implementation for ArrayBook. Very quick walkthrough. Any questions? No? Okay. Yeah, you can also try to follow the code yourself. All the code is available to you. Okay, let's see how we can do linked list. This one might be more interesting to you because you haven't done much exercises on linked list. So now we have to import the Java utility linked list. So now we're using some library classes from Java rather than developing the linked list from scratch ourselves. So now we have a linked book class, also generic, also implement the same interface book. And then here, rather than having two arrays, we have two linked lists. So for the first linked list, we say it should take a string for all the names because every element in the first linked list is a string. And the second line over here is slightly different. That is to say, we don't know yet what we're going to store as records because this E for linked book has not been instantiated yet. So we just say whatever E is, we're going to use the E over here. So as soon as we say linked book string, for example, we're going to replace this E here by string as well. Okay, that's how we're going to use it. So we have two linked lists over here. And then now the constructor is actually very simple. We simply just initialize two empty linked lists. Okay, remember, in linked list, there is no maximum capacity, so you don't have to worry about that. You can just dynamically increase the size of the list. Okay, and also for the size here, you can also return just the linked list size. So these are all the methods that are supported by linked list. You should really go to the API page and get used to it. Any questions about this? About these two methods? It's okay? Yeah. So now for the put and get, so we don't need any auxiliary method because index of somehow is already supported in linked list. So you don't have to implement by yourself. How do we do add? Similar idea. First of all, we say that if names, which is the linked list, if it contains is just another method in the library class. If the name already exists, then we can figure out the index. And index of is also another method in linked list. And similarly, so we can just remove the old record and put in a new record. Okay, that's and otherwise, if the name is not there, so we have to just add name and record to the end of each linked list. And for the get, similarly, we have to first of all figure out if the name is already there in the first linked list. If it is, then we can simply just get whatever index is for the name and go to the corresponding position in the records and get it. Otherwise, just return null. And that's it for the linked book implementation. So far we have seen several things. Okay? So we have an interface called book, and then under that we have two classes. So one is called array book, and the other one is called linked book. So here in the interface level, we have several methods we must support. So in the book level here, we have size, and we have put, and we have get, right? So now under array book, we actually have two arrays. So you have string array and also E array, right? So here in the linked book, we have linked list of string and also linked list of E. So just different attributes there. And both of them are going to support the same methods by using different data structure. Right? That's what you would do as well for assignment 4. Okay. That's a big picture. Okay, so that's about the implementation side. So now this is the question, okay, the problem for you. How do we test these two classes? So here we have one interface and two subclasses. How would you do it based on what you have known so far? How would you do it? How many JUnit classes do you need? Data? How many? Two classes? Okay, one for each. So you're saying maybe one is called test array book. The other one maybe test link book. Yeah, that sounds reasonable to me. Let's have a look. Although in this tutorial I'm going to call it the best solution because we have good solution. Okay, the solution you have learned so far, which is reasonable, but in this kind of case with inheritance, it turns out to be not so good. Okay, we will see why. So as Daniel said, we're going to do test array book and test link book. I'm going to show you the code very quickly to get an idea. And then, so these two classes are completely independent of each other, nothing to do with each other. So there's no code sharing whatsoever. Okay, so now we will see that there are issues, serious issues actually for this kind of strategy. Okay, let me just give you two hints for now, and then we'll see why these two things will actually rebel themselves very quickly. So one is about maintainability, meaning that it's hard to maintain your code or your projects. Let's say, in this case, we only have two possible implementations. What if I suggest 5 different possible implementation strategies? In that case, you need 5 classes. And maybe each class will look so identical to each other. Okay, that's when you have some trouble. Okay, we'll see that. And hint number 2 is about code duplicates. You're really trying to duplicate the same fragment of code over and over places. Okay, so these are the two biggest drawbacks for this particular approach. Okay, let's have a look at how you would do for these two classes first, and then we'll see exactly what the problems are. Okay, let's say we have a class called test array book, and now let's say we have 2 tests. Okay, so the first test, we're going to see how we can do insertion into the book. Let's say we have a phone book. The first one we say, we declare a phone book to be a book of string. And then here the dynamic type, as we said before, there are two possible dynamic types. It can be either array book or linked book. But in this case, we choose array book. Okay? And then let's say we want to let's say declare two phone numbers. So these two phone numbers are just different. And then we want to add Jin. We add Jin and phone number 1 into the book, and Alan phone number 2. Just add two records, named record pairs into the book. But now we simply want to test that the size of the book after inserting the two entries become 2. Okay? And also, if you want to generate a phone number for Jin, it will be phone number 1. And if you want to get a phone number for Alan, it will be phone number 2. Okay? So these are just reasonable. That's the first test. And the second test is to try. The second test is to see if we try to insert a name that already exists in the book. According to what I said in the beginning, we're going to overwrite the record there in the array or the linked list. So now let's say we have array book as the dynamic type, and then we do phone number 1, phone number 2, okay, different phone numbers. Let's say we do Jin phone number 1 first into the book, and then we make sure the size is 1. And now, also, if we want to get a phone number for Jin, it will be phone number 1. Let's say we now add Jin again to the book with a different phone number. Rather than throwing an exception, what we will get is the size remains to be 1. Okay, still Jin in the book. And then, if we want to get a phone number for Jin, it will be phone number 2, rather than phone number 1. Okay. So these are the two tests. Okay. So that's the test for array book. Now tell me something. Think about it for a minute. Let's say these two tests, the first one I insert two entries into the book. The second one I insert one entry and reinsert with the same name. So there's a rough idea for the two tests. If I want to apply the same idea to test linked book, would the code look very similar or very different? I want to do similar tests. Because somehow, one thing to note, these two classes, they inherit or they implement the same interface. As far as the interface is concerned, size, put, and get, they have some expected behavior, but they should be implemented consistently between the classes, right? So now, if I want to do the same two tests for linked book, how would the test linked book look like? Would it look very similar, or would it look very different? Okay, I heard similar. Salman, any thought?
I think so.
Similar. Tell me the difference if you think very similar. Would there be any difference? If you want to implement exactly these two methods for linked book. I think there are already some hints on the slides, if you're not colorblind. Huh? Yeah, that's good. That's the first one. Yeah, apparently it should be called test a link book, right? And then the second one is not just about name. That one is a little bit more like a deeper understanding. Sanjun, want to try? What will be the second difference? No idea? That's okay. That's okay. You can see that for these two tests over here, let's say for this line here, we say the dynamic type should be array book. It can be changed to link book as well, right? If I change that to link book, then should I change the rest of the code? I don't have to, because let's say for line number, this line over here, when I try to say phone book.add, as we learned from 114, this line here will compile simply because add is defined in the static type of phone book, which is book, the book interface. And the book interface does have this put method defined, right? That's what we learned from 114 in the review lecture. So now, depending on what the dynamic type for phone book is, in this case, it is array book. So that makes sure if you call add, it's going to call add the version of add in array book. If I simply change this yellow part here to be new link book, then everything else will still compile. But now, if I try to execute this line here at runtime, it's going to call different version of the dynamic binding is about. Okay? So the answer to my previous question was, if I want to define the class for test linked book, it would just look like this. You see the swap? Okay. So only changed the name, and now we just have to change the dynamic type over here. Okay? You can see basically for every test that we can do on the array book, we should be able to do them in a very similar way for linked book by just changing the dynamic type. And the issue here is actually illustrated. And here you can see we got lots of duplicates of the code. You have to copy and paste basically the same amount, the same fragment of code in two classes, and then only change the new part over here, the dynamic type. Does everyone got this? Okay. That's very important insight into the issue, so we can see how we can improve the solution to a better one. Okay, that's about it. And let's see. So here, that's exactly what it says. So because these two classes implement the same interface, but they must implement all the methods in a consistent way. Okay. You cannot say somehow if you call size in the version here, it's going to return the number of entries in the book, but here it's going to return a different number. No, they have to return the same. Okay. They have to be implemented in a consistent way. Okay, so we got lots of duplicates. Lots of duplicates. Okay, that's all we have understood. Okay, so now how should a good solution look like? Let's talk about it. A good solution is somehow, let me go back to the that solution here. So somehow we want to share everything by the yellow parts between the two classes. That's what we want to do, between the two test classes. The yellow part, somehow we can make them abstract. Okay, so now we talk about abstract classes. Okay. Let me just tell you the solution quickly, and then we'll go over the slides, and we're done. We don't have too much time. So this is the inheritance hierarchy for the book and also the two implementations. And the test itself has similar architecture. So we're going to have test book, which itself is abstract. Okay, over here. And then we also have test array book. And also we have test linked book. The way we do this is by saying, so somehow you can see we have two test methods here. I'll just say T1 and T2. So we put T1 and T2 over here. So they will be shared between these two classes, right? Okay, that's the sharing part. However, you can see the only difference is about how we define the new part, the dynamic type. For that, we have to define an abstract method over here. Define an abstract method here, which is going to return back to you a book objects. And then it's called a book. I'll talk about this in detail in a moment. So that's the critical parts about this solution. So somehow we define T1 and T2 in this centralized place, which will be shared between the two subclasses. But meanwhile, we have to also take care of the yellow parts. The yellow part has been factored out into this particular method over here. So we don't tell you what book is going to return at this level here. But now, when we are here, we can tell you the book is going to return an array book. At this level here, we tell you the book here is going to return a linked book. Okay. That's kind of the rough idea. Let's see. Okay, so now let's go to the good solution here. So here we have to factor out all the common code into this textbook class. That's point number one. And also, we have to somehow to say, over here, we have to define some abstract method. Okay, so you can read out of the text yourself. Basically, that's exactly what I said. So here, in the text method here, we have to somehow put a placeholder here, because this can be either a array book or it can be a link book. That's why I put an empty box there. It can be either one. That's polymorphism part. Okay, so this is the abstract method over here that we define. Okay. Okay, let's see the code. And there is a particular name for this. Maybe when you go to 219, you did talk about the sign patterns for programming. So that's called factory method, just for information. But I just have to know how this works. Okay, let's have a look. So now this is exactly the inheritance hierarchy we have. So we have one class for testing the book, being the abstract class. We have one class for testing the array book, have another class for testing the link book. Okay, let's see how we do it. Let me show you the code. So now the test book, which is over here. So now we're going to define T1, T2, and the abstract method. These are the three things we need. So now here we have the abstract method here. You can see signature only. Okay. So this method here will be supplied with concrete implementation in here and in here, but not at this level. So now let's see the two tests that we saw before. So now the critical line you should look at is this. Okay, that's a critical line. What we did in the previous slides, we have to duplicate the same amount of code in two places, right? And in the array book class, we have to say new array book. In the case of the link book, we have to say new linked book. But now we factored that out already. So it's now referring to whatever that's returned from this method here. But this method is still abstract. We don't know what it is going to return yet. But we will know when we get to these two classes. Okay? So we just change that line, and then the rest is the same. So this part can be shared. Okay? And then when we go to the second test, so this is, again, using the book, the factory method over here, and then the rest is the same. So now this part is defined only once in this top class over here, only once. And it will be inherited to these two classes. And all we got to do for these two classes will be to give concrete implementation for this abstract method. That's what we got to do. Okay, let's see, for example, this one, if we have test array book, we don't have to duplicate the code anymore. All we got to do is to define the concrete implementation for the book method here. Can you imagine what I'm going to return? One line solution. Yeah, you got it. Yeah, actually set in the slides. Just return this particular dynamic type. That's all you got to do. That's the complete definition for this particular class. You don't have to repeat T1 and T2 anymore. You only have to say, for this book over here, which was used in the superclass, we're going to say what image should be returned. Okay, so that's for test array book. And if you do test linked book, similarly, you just got to return another dynamic type linked book over here. So that's it. So now imagine that if I have 5 possible strategies for implementing the book, I have 1, 2, 3, 4, 5. Every time I add a new subclass over here, I only have to just define that kind of one-line solution only. I do not have to repeat T1 and T2 in any way. Okay, so it's completely shared. So that's why this solution is much better than what we learned so far. So you will be required to apply this for assignment 4. Okay. So now here we have, so basically all the methods are, the 2 test methods are inherited to these 2 classes. And so now one more thing to mention that's really critical. Okay. So now so conceptually, so T1 will be inherited, I'll just say green. It will be inherited somehow to this class, and also T1 will also be inherited to this, right? And remember in T1, we make use of book somewhere. And also in here, we make use of book somewhere. But in this class here, we actually say for the book method, this is what you return. You say return array book. And here, on the other hand, for this class here, for the book method, you return the linked book. Okay? So now we have to see how polymorphism and dynamic binding is going to come into play. Okay? Things will work just smoothly. Let's see. Again, T1 and T2, let's say for T1, T1 is inherited to both classes. And because T1 somehow makes use of this book class, book method, which was abstract at this level here. But in this class here, since we defined to say book should return an array book object. On the other hand, here we say that it's going to return a linked book objects. So let's see how that's going to work. Let's consider this. If you have, let's say, some test book objects here, that's a static type. So now we say you have it to be test array book. So now if I try to say, so this guy here, T1, okay, if I say test.T1, how does dynamic binding work over here? So test has the dynamic type of test array book. When you say test.T1, it is going to call this version of the T1. Specifically, the book here is going to call this version of the book, which will return an array book. Okay, that's kind of complicated, but hopefully you got a big picture. You really have to see the complete code to study that carefully. Let me repeat again. Okay, so now since when we try to execute this line over here, test has the dynamic type test array book. So when you try to say test.T1, it is going to call this version of T1, which is inherited from this abstract class over here. And specifically, T1 makes use of this book method, which used to be abstract. But now, in this class here, it is defined by saying it's going to return the array book specifically. So it's going to call this version of the book objects. So now let's do another one. If I change the binding of the test to test array, the typo to be link book. If I change to link book here, in that case, it's going to call this version of the T1, and when I use book, it's going to call this version of the book, which returns a link book objects. Okay, that's how polymorphism and dynamic binding work altogether. Okay, that's exactly what I said. Okay, one more thing. So, since now we got two test classes, you don't necessarily have to run them individually. There's some code. There's something called test suite in JUnit. This part of the code you don't have to memorize, just make use of them by copy and paste. You can see the complete code example. So suite simply just contains different test classes. But here, basically everything here will just be standard, just copy and paste, except for this list over here. So now I want to run test array book, and then followed by test link book, one by one. Okay? And then that's it. So now, one more question. So here you see that we did not list test book in the list. How come? We're saying we're going to run test array book first, and then test link book. But we did not say we want to run test book. Do you see the reason for that? What's so special about test book?
It's abstract class, so the methods are not inherited.
It's abstract class, and the book method here is abstract, so nothing for you to call yet. So that's why you have to call the concrete classes. Okay? Good. Okay, so any questions about this? So for assignment 4, you are only allowed to create new classes in the tests package. But for the implementations or for interfaces, you are not allowed to. Okay, so you must apply this strategy here for assignment 4. I think that you will map quite nicely to assignment 4 because you just have to have one class called test array set and one class for test link set, right? And then you have to define another class that we call test set with the abstract method to return whatever set object it is, right? Okay, any questions? Okay, so what about we take just 2 or 3 minutes break and then we'll resume the lecture.